Welcome to myprojectbazaar.com. Let me discuss about the project robust and effective component-based banknote recognition for the blind. Let me discuss about the abstract of the project. Banknotes recognition for visually impaired people has been done by automatic method. This new approach can efficiently recognize the banknotes with the features. With this new algorithm provides high accuracy, high true recognition rate and low false recognition rate. Also provides high efficiency and recognition banknotes quickly. To make the system robust, speeded up robust features algorithm proposed. SURF is a robust local feature detector that can be used in computer vision tasks like object recognition or 3D reconstruction. SURF is based on sums of 2D hardware responses and makes an efficient use of integral images. It uses an integer approximation to the determinant of Hessian blob detector, which can be computed extremely quickly with an integral images, that is 3 integer operation. SURF descriptor is based on similar properties with a complexity stripped down even further. The first step consists of fixing a reproducible orientation based on information from a circular region around the interest point. Then we construct a square region aligned to the selected orientation and extract the SURF descriptor from it. The proposed algorithm has been evaluated by dataset to a variety of conditions including occlusion, rotation, scaling, clutter, background and illumination changes, viewpoint variation and one and or wrinkle bills, and further by blind subjects. For feature description, SURF uses wavelet responses in horizontal and vertical direction. Again, use of integral images makes things easier. First, monetary features of each query images are extracted by SURF. These features are then matched with the pre-computed SURF features of reference regions of the ground truth image in each background category. The numbers of matched features are compared with the automatic thresholds of each reference region to determine the banknote category. The special information of matched SURF features to avoid false recognition, that is, recognize negative images as banknotes. Patches with respective features for each banknote category are selected as reference regions to match with query images. These SURF descriptors, our component-based framework, generates more category information that is more discriminative to distinguish a query image from occlusion, and the spatial clustering approach is effective to filter out negative images by using the spatial relationship between matched points. Let me discuss about the flow diagram for our process. Here there are two phases. One is training and another one is testing. In the testing phase, query images is the input image. It was load and convert the grayscale image and make preprocess the query image. In the preprocess step, we filter noise in the image using Gaussian filter. Next, we extract the descriptors and the detectors using SURF feature extraction. For orientation assignment, SURF uses wavelet responses in horizontal and vertical direction. For a neighborhood of size 6, adequate Gaussian weights are also applied to it. Then they are plotted in a space as given in below image. The dominant orientation is estimated by calculating the sum of all responses within a sliding orientation window of angle 60 degrees. Interesting thinking is that wavelet response can be found out using integral images very easily at any scale. For many applications, rotation invariance is not required, so no need to find things orientation, which speeds up the process. In short, SURF adds a lot of features to improve the speed in every step analysis, so it is 3 times faster than SIFT. While performance is comparable to SIFT, SURF is good to handling images with blurring and rotation, but not good for handling viewpoint changes, that is illumination changes. This process will be repeated for all trained data set also. Then in the classification stage, matching features are clustered using the spatial clustering of matching features. After feature extraction using SURF, the extracted feature has been matched with the database image to recognize the output. In order to improve the performance for rotation, the descriptors based on multi-orientation, the many to many tentative correspondence are determined with a maximum distance. Half transformation is used to reject the mismatches, and the affine parameters are computed with the least square solution. The image matching algorithm shows a better performance for image rotation than the standard SURF, and it succeeds in matching the image including repetitive patterns which will deteriorate with the distinctions of feature descriptors, encode distinctive local structures at a collection of image points for matching between images, despite modest changes in viewing condition, that is changes in scale, orientation, contrast, etc. Finally, recognize the banknotes, analyze the match features with query image and also with dataset images. Maximum number of features are provided the recognized output. Let me discuss about the running procedure for our process. Select the bank.m file in the current folder, right-click that file and run for executing this process. This is the main window for the banknote recognition. By pressing the read input image button, we can browse the images from the dataset folder. Select any one images from the dataset folder. I display the original image in the access one plot. By pressing the resize button, we can perform the cropping process. So perform the cropping process with the specified dimensions. So here I display the resized image, and by pressing the filter image button, we can perform the Gaussian filter noise removal process and display the filtered result. By pressing the gray image button, we can perform the grayscale conversion from our color image to grayscale. So here I display the grayscale image. By pressing the fair feature extraction button, we can perform the feature values in a table format, and this is the image representation with features. By pressing the next button, we can go to the matching window. This is the matching window. Here by pressing the matching points button, we can perform the matching process with the database. So this process will be repeated for entire data set, and this is the matching feature with the query image and also dataset images. After matching points process completed, we go to the next button for output window. This is the output window, that is final window. By pressing the result button, we can perform the result, that is obtain the final result recognition of note. Finally, we recognize the note as 500 rupees note, and I display the recognized result in a maximum matching point features with the query image. A feature-based image sensing model is proposed, which senses the similar image based on the feature extracted. Proposed method is identified to sense a large number of images correctly compared to the previous method. The feature-based approach senses the image more accurately compared to other approaches. Thank you.